Bismillahirrahmanirrahim. Assalamu alaikum. This is Mohammad Faraz Faruqi here to present my final year project titled as Dead Food Classification using Machine Learning. So as I introduce myself, I am Engineer Mohammad Faraz Faruqi, and along with my group member Engineer Mohammad Akhtar, our project was supervised by Dr. Junaid Bhattisa and our co-supervisor was Dr. Gulsher Ali. So let's proceed. So let me give you a overview of how we will proceed in this presentation. So first of all, I will introduce my project, what is it about, and after that our problem statement and aims and objectives of our FIP. Moreover, methodology and results will be discussed, and finally conclusion and future recommendations will be discussed. So first of all, introduction. As we know that Pakistan is rich in producing different dates varieties and currently ranks at first fourth in largest date producing countries. So Pakistani dates are very famous for their flavor, taste, softness, and sweetness. Date palms are cultivated in all the four provinces of Pakistan in Balochistan, KPK, and Punjab. Among all the provinces, Sindh and Balochistan are leading provinces in producing multiple varieties of dates. So our problem statement is that date fruits are very abundant and popular in Pakistan and have growing international presence also. There are many different types of dates, each with different features, colors, and sizes and taste. Therefore, sorting or classifying dates is a key processing factor in the industry and also can be a tedious job, time-taking job when it comes to do it by hand without automation. Therefore, the aim of this study is to classify the different types of dates using machine learning method. Let's proceed. So the aims and objectives of our project are basically there are 40 unique types of dates, 400 varieties which cover a wide range of taste, shape, and color as well as price and importance also. The process of dates is therefore very important, particularly because a large percentage of consumers cannot differentiate many different types at hand. Therefore, aims and objective of our study is to classify dates for automated classification in the factory. Moreover, we are aiming to make an app for consumers in which they can uh, click an image of any date and the machine learning in the backend will tell that which date is in their hand, meaning completely automation using machine learning in this field of dates. Let's proceed. So in methodology, first of all, we started uh, by collecting our data set. After the collection of our data set, we divided the data set into train and test. After the collection of and division of our data set, then we proceeded to train our models. So we chose three models, namely CNN, SVM, and LR. After that, the results were obtained and we compared all the models by their performance on our data set, which was original data set and also the noisy data set. After that, we chose the best performing model, which was performing better on both the data sets, and hence we completed our project in that manner. So in our data sets, the data set consists of 1,399 high quality JPG images, in which each image shows a single date fruit type out of 7 date types. 7 date types we collected in our data set are Ajwa, Ambar, Asil, Muzafati, Zaidi, Kalmi, and Khorma, which are native to Pakistan and Saudi Arabia. While making the dataset, control environment was constructed to take the pictures of this all the different types of dates apart from Saudi Arabia and Pakistan. The imaging setup consists of smartphone camera, Vivo S1 AI triple camera of the smartphone. The dates were put on an elevated platform behind a white background. The distance between the table and the camera was maintained for all pictures, which was 15 centimeter. We collected two data sets, namely clean dataset and noisy dataset noisy dataset only for testing limitations. Below are the given links for noisy dataset and clean dataset on Kaggle. So these are the samples of our dataset. Firstly, clean dataset. We can see that how we have taken the pictures on of the dates on a light room, and background is also white and fixed distance is maintained. Moreover, noisy data set was collected in different conditions and at different angles and in different light conditions. ML models, then after the collection of the data set, we chose our models which were previously described, like machine logistic regression, SVM, support vector machines, and CNN, convolution neural network models. After we trained the data set on all three models, next we were to compare the performance of all the models and choose the better performing model on both noisy and clean data set. So these are the result of CNN models. As we can see, this is our model, CNN model, which we performed on our data set. So in CNN model on clean data set, we achieved the accuracy of 99.5%. This was the model accuracy curve of our CNN model on clean data set. As we can see, the training and validation curve are catching up and are remaining constant throughout. It shows that the high performance of the dataset CNN model on clean dataset. Right? And after that, this is our confusion matrix, which shows that only AJWA in AJWA category, the CNN model has predicted two wrong predictions. Otherwise, all other five categories, it has correctly classified 20 out of 20 testing images. Let's proceed ahead. Advantage of CNN model was found that it also performed better on noisy dataset, and as we can see that it acquired the 98% on the noisy dataset as well, and only three images were not classified. In the confusion matrix, we can see that only three images were not classified correctly, and all other six categories were classified correctly, 100%. After that, we move to our logistic regression model. As we can see that after 10 iterations, we acquired the 97.8% testing accuracy on clean data set. We can also see that accuracy curve of the logistic regression, which is in the start, we can see that testing curve is very far from training curve, which shows the less accuracy, but after the iterations goes to 10, we can see that it is finally catching up to the training accuracy. Hence, we can see that it performed 97% accuracy on the clean data set. So limitations of LR as compared to CNN were found that on clean data set, it performed well, and only three images were classified miscorrectly. And after that, on noisy data set, we saw that it performed very badly, and only Only one category was completely classified correctly, and all other categories were have negative classification and could not classify correctly to the images in different categories. So furthermore, we move to our support vector machine model. We can see that its performance on clean dataset was noticed as 95.7%. Limitations of SVM model were found that similarly as compared to convolution neural network CNN model, SVM performed better on clean dataset, but as compared to the CNN model's performance on noisy dataset, it did not perform well, and we found that it could only acquire 40.8% accuracy when it comes to the noisy dataset. Let's move forward. So in conclusion, after we trained our three models, the conclusion we made that after seeing the results that convolution neural network performed better on both the dataset, noisy and clean dataset as compared to support vector machines and CNN convolution neural network model. So now this base model, which is CNN, can be used for real world applications such as industry data classification, and also can be deployed as a web application on or Android application for the customer use. Future recommendations. So finally, we future work on our existing dataset and model can be carried out on a quality disease detection and prediction of deaths, and hardware solution can be provided for aflatoxin detection, which is a major cause of Pakistani deaths being rejected at international level due to standards due to the poor quality. So finally, thank you for watching. Follow us on e.sibayu on our Facebook channel, and also on YouTube. You can follow us as E Sibayu. Thank you for listening. Allah Hafiz.